Hello, welcome to lesson 4.3, where we are going to be talking about the transformations of absolute value parent functions. This is going to be a kind of a 2-day event here, so let's get started. For today, you'll just need the lesson 4.3 day 1 note sheet, which I've posted to Google Classroom, and you'll want a pen or a pencil and probably your calculator, so you can kind of be looking at how these graphs will move, okay? So that being said, we are going to today identify transformations of absolute value functions, and we are going to graph those transformations, okay? So let's go ahead and get started. So it says here the learning targets, which we just talked about, and then it says the absolute function f of x equals the absolute value of x is the parent absolute value function. So hopefully you've heard of this before, but recall that a parent function is the most basic function of a particular type, and then transformations may be performed on a parent function to produce a new function. So actually, the parent function of an absolute value function looks like this. So if we have a graph here, okay, so if you were to plug in, let's say, to find your x and your y's, right? And you're plugging in to find the parent function. So let's say you have y equals the absolute value of x. That's the parent function, right? So if you plug in, let's say 0. Well, what's the absolute value of 0? 0. So there's your first point. Then if you plug in 1, what's the absolute value of 1? 1. So there's your second point. If you plug in -1, what's the absolute value of -1? Positive 1. So there's your third point, -1, 1. And if we did 2, it's 2. And -2 is also 2, and so on and so forth. So you get this perfect V-shaped graph, okay? And that is what your absolute value parent function looks like, okay? So that's the first thing I have here. It says any absolute value function will have the shape of a V, okay? The parent function y equals the absolute value of x will have a vertex of 0, 0, which we also saw here, okay? So those are important. And then if you look over at this math tip here, what we're going to talk about is how we can transform that parent function. So it says vertical translations which shift a graph up or down, and horizontal translations which shift a graph left or right. Those are the two we're going to focus on, or those are the things we're going to focus on today. Okay? So vertical shifts k move the entire graph up or down. So y equals the absolute value of x plus k is going to move the graph up. Okay, so that plus k means it's going to move it up. Y equals the absolute value of x minus k is then obviously going to move your graph down. Okay, so if we have y equals the absolute value of x minus 9, it's asking you to identify the transformation from the equation or graph. So in this case, we know that the minus 9 would move your parent function down 9 units. Okay, and in part B, y equals the absolute value of x plus 7 would move your graph up 7 units. So in part C, I need you guys to answer what would happen here. And hopefully you answered that it would move your parent function down That -6 would move it down 6 units. Okay? Now, in parts D and E, it's asking us to also identify the transformation, but based on the graph. So remember, in this case, that our original function started at the origin, so at 0, 0 in both of these. So then you just have to realize, okay, how far up or down did it move? And in this case, it moved up 3 units. So you would say up 3. And obviously in all of these, I do mean units, okay? And then in part E, it has moved down 4 units. Okay? Cool. All right, then moving along here, now we're kind of looking at the opposite way where it's asking us to write the equation given the transformation. So in this case, and again, you can write it as y equals f of x equals whatever you want. But if it has moved up 8 units, we would write that as y equals the absolute value of x and then plus 8. If it has moved down 5 units, we would write that as y equals the absolute value of x and then minus 5. All right, so that is how a function or an absolute value graph would move up or down, plus k or minus k outside of the absolute value bars. Okay, that is a vertical shift, up or down. Now, a horizontal shift moves the entire graph. Oh, that should say left or right. Okay, so left or right. All right, so in this case, and this is kind of the opposite of what you would think, right? Because normally you would think that moving to the left would be the minus, okay? But actually, in this case, moving to the right would be your minus. And moving to the left is going to be your plus. And that's because, I don't know if you guys noticed this in the beginning, but the original equation has a minus there. Okay, so if it is a minus, that means you're moving to the right. That's your original. But if it's a plus, that means it's like minus a negative. So that actually means you're moving to the left because the left is the negative side of your graph. Okay, so you just have to remember that. So in this case, this would mean, and it has to be inside the absolute value bars. So in this one, it says y equals the absolute value of x minus 9. So this moves to the right 9. And then this one says y equals x plus 7, absolute value of x plus 7, all inside the absolute value bars. So this means it would move to the left 7. And then go ahead for part C. I'd like you to answer, what do you think it does? Y equals the absolute value of x minus 6. And hopefully you answered that it moves it, your parent function, to the right 6. Awesome. All right, then just like the last page now, we know again that it usually starts at 0, 0. So now we are looking, did it move left or right? And in this case, it moved to the left 1, 2, 3. From our original point. And this one, part E, moved to the right 1. Okay. And then the last part, let's go ahead and make sure we can write some equations. Okay. So if it's saying it moves to the left 2, we're going to write that as y equals, and that should be x plus 2, all inside the absolute value bars. Okay. And then part B, y equals x minus 3 if we want it to move to the right 3, all inside the absolute value bars. Okay? So again, those are your horizontal shifts. Those are what's going to move your absolute value function left or right. Okay? Last thing for today, let's try putting those together. Okay? So the first thing we're going to do when we're trying to put it together is first figure out what should happen. So identify the transformations and then we'll graph it. Okay? So first thing, we have that minus 2. So we know it's going to move down 2. And then we have also this x minus 3. So we know it's going to move to the right 3. Okay, so remember that your original or your parent function starts at 0, 0. So now from that point, you want to move it to the right 1, 2, 3 and down 1, 2. And that's going to be its new starting point. And so remember that on each side, it really just goes up 1 over 1. And so it looks like this perfect V going this way and this way. And that's it. That's your graph. Okay. So again, let's try this next one. We know that this is the original origin. And we know that this one moves up 1. And this one moves left 4. Okay, so again, to the left 4, 1, 2, 3, 4, and up 1 would be right here. And then we know it is a perfect V looking like that. Okay. All right, and very last part for today is writing an equation now given both pieces of information. So if we know it went to the left 6 and down 3, this would look like y equals absolute value of x plus 6, because that's left 6. And then down 3, you would end your absolute value and put a minus 3 on the end. Okay. Same idea here, y equals, and that's going to be to the right 4 is going to look like x minus 4 inside the absolute value bars, and then up 5 would be that plus 5. Okay, so that's it for today. The only transformations we talked about are your vertical and your horizontal shifts, and those are going to, vertical are going to move your absolute value parent function up or down, and horizontal are going to move it left or right. Okay, so tomorrow we'll talk about more transformations, but until then, have a good one. Bye-bye.